Thank you very much, Isa. So, yes, just to give you a bit of introduction to who I am. As Isa said, I used to work for Geovation. I worked there for about 5 years as one of the senior engineers. And a year and a half ago, I decided it was time for me to move on from Geovation, but carry on doing the stuff I was doing there. And I now operate as a freelance fractional chief technology officer, which is to say, I offer my services for any number of days per week that people want to engage me for, which enables people who can't afford a full-time chief technology officer to take advantage of my services and skills. Now the advert's over, I'm going to move on to the task at hand, which is the presentation. I'm going to be changing my screen so that you can see the presentation and not end up looking up my nose all the way through, which will be much more pleasant for you, I think. So just 1 second, if you bear with me. There we go. So hopefully now you should be seeing my screen. So let me start the slideshow. Oh, hello, what happened there? There we go. Right, sorry, disappeared.
And we're back.
And we're back. So yes, the title of this particular webinar is How to Scale Your Tech to Meet Your Business Needs. So learn how to grow your tech to meet your demand while preparing you for the future. So what does it mean to scale and why do we scale? So I'm going to be talking in averages and generalities, obviously, because I don't know the circumstances of your individual startups. But most startups follow a similar path, which is to say that it takes approximately 3 months or so to establish what we would describe as problem solution fit. In other words, excuse me, in other words, you have done all of the workshops and sessions that you need to examine your value proposition, the assumptions that are contained within that value proposition, personas that describe your customers, and generally put yourself into the shoes of the people for whom you are creating your product or service. So you've identified a need that you believe is significant and is unmet or is not met well by the market. And you've come up with what you think is an answer to that need that people will pay for. So as I say, roughly 3 months to achieve that, that milestone. Generally speaking, from starting up, it will then take you another, let's think about this, 21 months. So it takes about 2 years to get to the point of achieving what we describe as market product fit. Notice that I say it that way. You will often hear this referred to as product market fit. I very specifically don't call it that. I have a bit of a bee in my bonnet about the importance of words and how they change your thinking. And if we describe this as a product market fit, it puts the product first, and the product should never be first. It should always be the market that dictates what you do. So market product fit after approximately 2 years. By the time you've reached market product fit, you are probably ready to achieve scale. And generally, what we mean by that, and this isn't based on my analysis, this is based on the analysis by a great many people, but principally people like Paul Graham, who, if you haven't heard of him, he's one of the co-founders of Y Combinator. And he, amongst others, looked at the growth rates of successful startup businesses that had achieved what they described and what they felt was market product fit. And what he and others have found is that from that point, startups which are performing well generally achieve somewhere between 5 and 7% growth per week. Now, if you scale that up over the year, what that comes to is approximately 12 times the number of customers at the end of that year compared to the number that you had at the start of that year. So given that we are working in orders of magnitude, let's round that down and say you need approximately 10 times the number of customers once you've achieved market product fit to be described as working at scale. So if you think about that, what that means is, let's say in 3 years' time, when you're at scale, let's say you have 5,000 customers. That means in 2 years' time, you will have 50 customers. In 1 year's time, you will have 5 customers. Okay, that's the general growth rate. And obviously there are individual differences, but overall, that's how it works. However, in order to get to the point of market product fit, that means you've got 2 years worth of developing something. What is that thing? And generally we refer to it as a minimum viable product. Well, that is to say the literature refers to it as a minimum viable product. I don't, and anyone who's ever spoken to me before will understand why. It's because it's never going to be minimum, it probably isn't viable, and it's certainly not a product. So let's call it a prototype, okay? For those first 2 years, you will have developed a prototype. And then you suddenly reach the point where you're going from having serviced 5 people at the end of the first year, which is fine because your prototype, shaky though it may be, is probably capable of dealing with 5 customers. But you now got yourself to the point where you've got 50 customers. And things are probably starting to creak a little bit at the seams. Now, scaling up is one of those things which is a little bit like optimization in software. You never optimize software until you need to do so. And the reason is that you don't know what you need to optimize until you've let it run for a while. If you try and optimize software before a problem has manifested itself, then you will never get anything finished. It's slightly different with scale. You don't build for scale until you've established market product fit, because if you do, you're going to be spending a great deal of time and money potentially developing something which doesn't work for your customers and which you will have to pivot from. So let's suppose you are currently in a position, or looking at very soon being in the position, where you've been going for a couple of years, you've got market product fit. What sort of things are you going to be looking at that will be worrying you when it comes to achieving scale? And this list is by no means comprehensive. It's just a series of things which I've come across in my dealings with the, oh goodness knows, 250 odd startups that I've worked with up until now. So one thing which I've come across which is very common is that your prototype, your MVP, whatever it happens to be, because you're still in the process of trying to establish exactly what market product fit is, the likelihood is you're going to be much more, shall we say, responsive to what your customer tells you they need than you would like to be with your product going forward. And what I mean by that is, just because one customer says that they want something does not mean that it is worth your while developing that feature, because it may only be one customer who needs it. However, as I said, when you're getting to the point of achieving market product fit, you're probably going to be doing a lot of the things that your customers ask for in order to find something that resonates with all of them. Chances are that's going to mean that you have potentially several versions of your code base, each of which has been customized to an individual customer. So they are diverging. Something which you will almost certainly be having to deal with is manual processes. It is in the nature of startups that everyone would love to be able to automate everything from the get-go, but for exactly the same reason that I've just mentioned, whereby you end up with potentially different versions or and accommodating the requirements of your customers until you reach market product fit. For the same reason, you don't want to go spending money on automation because you're going to be far too busy doing a lot of other stuff before you reach market product fit. So that means you've probably got a number of people who are running around like the proverbial blue-ass fly, trying to service your customers, be it onboarding, be it maintaining them, be it establishing relationships with them, be it operating your back office, whatever it happens to be. there's probably going to be a lot of stuff that you're doing manually that you would wish to do automatically. You are probably in a position where you have maybe 1 or 2 developers. They might be part of your team. They might be developers that you've engaged with from a platform like Upwork, for example. I would imagine if you've got to this point, at least one of those developers is probably looking extremely tired, if not exhausted, because they've been running around, again, like the blue-ass fly, in order to be able to develop your product to the point where you've achieved market product fit. Beware, this is typically the time at which developers like that who've been involved at the start of a project get itchy. And what I mean by that is chances are you've brought them into your company in the first place because they are relatively more junior and therefore cheaper. And they've just spent the last 2 years operating to build up a business. So now they've got a CV that says, I've built a business. It may not be their business, but they've been the ones who've created all of the infrastructure and code so far. You've been working them hard because you need to get things up and running. They're probably at the point now where they're exhausted and thinking, do you know what? I can go and join another company, earn 3 times as much with the experience I've got with these guys. And yeah, I'm off. It happens a lot. You will probably be experiencing what we describe as technical debt, whether you know it or not. And what do I mean by technical debt? It's a term that describes the fact that, much like the rest of life, probably more so than the rest of life, there are a few things that we can be certain of, but one thing we can be certain of, other than death and taxes, is change. Change is almost the lifeblood of the software world. If you've been going for a couple of years, chances are there will be a newer, better technology, although I would question that, but that's not the point of this discussion. But it will certainly be the case that whatever technology you have been using up until now will probably have released one or maybe several major versions since the time that your developers started creating your product. Okay, so it's changed. And in order to keep up with that, you need to change as well. And there might be dead ends, things that you've created that ended up not being useful, that are still in the code base. There will be things that you could and should have done better, but you didn't have the time to do them better. All of these things are what we describe as technical debt. And whether you know it or not, you will have it. And the final point on this is what I describe as inappropriate infrastructure. What I mean by that is I am assuming that everyone here, whatever computing infrastructure they have, is on the cloud. If it is not, you are already in trouble. You need to be on the cloud. You should not be hosting anything yourselves, apart from 1 or 2 very unusual circumstances. There's a good reason for that, which is that cloud providers spend all their time managing infrastructure. You don't want to be doing that. What do I mean by inappropriate infrastructure? Well, you may have started off with one set of tools provided by your cloud provider, but as with anything else, like I just said, change is the lifeblood of software. Those tools will have changed, and they might be cheaper or better in their newer form, and you need to look at your costs because you're going to be having a lot more customers now, and the infrastructure you're using is going to get a lot bigger and it's going to cost you a lot more money, especially with electricity prices increasing. We're going to see big increases in cloud costs. Okay, so maybe you need to change your infrastructure to be in a more appropriate position for the larger amount of infrastructure that you require. So there are 4 elements of scale, I think. This is my definition. This is a bit like, I remember one time, a long time ago, hearing that there were 4 kinds of joke, and I was thinking, oh, that's brilliant, I'll be able to make any joke I like, until you discover that the 4 kinds of joke are plays on words, plays on situations, absurdity, and whatever the other one else is. What I mean by that is, yes, there are essentially 4 elements of scale, but they cover a multitude of sins. However, we will take these in order. The 4 elements of scale, as I see them, are first and foremost objectives. So understanding why you are scaling and what you're trying to achieve by scale. Because if you don't know that and you're not clear in your mind, it will not work, no matter what you do. The second key point, which comes immediately afterwards, is your team. Have you got the right team? And if not, what do you need in the right team? Once you've got the team, actually the most significant way of achieving scale is through process. And the processes that you use to take yourself from a manual situation into an automatic situation. And finally, as I mentioned just now, there is the issue of infrastructure. Have you got the right infrastructure set up in the right way that is appropriate for you and your product? So, you may have any number of objectives for scaling up, but if there's one objective that I can pretty much guarantee, it's that you want to achieve growth and more revenue, more customers, more revenue. You may be wanting to perform some kind of rationalization at the same time. Now, what do I mean by that? This goes back to what I discussed about technical debt. So up until now, you have had a prototype and you've been changing that prototype in your search to find market product fit. So it is only at that point that you can start actually developing what we would describe as a product. You don't have a product until you get there. So now you're moving from code that was developed to create a prototype to something which is concrete. You know, hopefully, what it is that you want to build, but there may be a much better way of doing it than the one that you started off with. So that's what I mean by rationalization. If you haven't done so, you may be wishing to move to self-service, and that can mean a multitude of things, not the least of which that you relieve yourself from all those back office tasks that you've been having to do in order to onboard and support customers, which relates to this idea of automation. You want to be able to deal with more people in a shorter amount of time. And ultimately, a lot of this also comes down to cost, because as I mentioned previously, the more customers you have, the more infrastructure you need to support them, and the more that's going to cost you. You need to be looking at your optimizing your cost for scale. So let's have a look at the team. There was a book written in 1975 called The Mythical Man Month by a gentleman called Brooks. I forget his first name. And if you haven't heard of it, The Mythical Man Month is pretty much a standard read in the software industry, and it's well worth you taking a look at it. It's been updated and reprinted a couple of times since, the last time in the 1990s. But nonetheless, what it says holds true even today. And I'm skipping to the second point first because I should have put these the other way around. Brooks's law is the most important thing. So what is Brooks's law? Okay. When you think about your team, I would imagine that in order to scale up, it would occur to you that instead of 1 or 2 developers, you might need 10 or 12 developers, because surely 10 or 12 developers are going to be able to create the product that you want faster than 1 or 2. I mean, that seems logical, and there are plenty of areas in our lives and plenty of processes and products and services in which that relationship holds true. You get more people, you get more productivity. Unfortunately, software is not one of those things, okay? What Brooks found out, he used to work at IBM, and he performed a big study of his projects that he managed at IBM and what happened when he did what would seem to be the logical thing, which was to add more developers to try and get the product done faster. What he discovered was that adding manpower to a late software project makes it later. And this idea of the mythical man month in the title of the book comes about from the fact that a man month is a hypothetical unit of work representing the work done by one person in 1 month. So what Brooks's law is saying is that the possibility of measuring useful work in man months when developing software is a myth, right? And there's a reason for that. And the reason is software projects are inherently complex, and it is almost always impossible to break them down into units that are completely unrelated from one another. The consequence of that is that your developers need to communicate with one another, and the things they are developing need to communicate with one another in order to work. So what happens as you assign more and more people to a project is that it requires more and more communication, which takes up more and more time, leaving less and less time for the development. Apart from anything else, anyone who comes on new to the project has got to learn about the entire context of what they are doing. And if you have 10 people working on a project, each of those 10 people has to communicate with 9 other people, right, in order to get it done. And it becomes unmanageable for them. So it is an almost irrefutable law with respect to software projects that throwing more people at the problem actually makes it worse. So you're in a position where you maybe have 1 or 2 people. What's the breaking point, as it were, the break point? Because actually there is an advantage to adding more than 1 or 2, but fewer than 10. And that point comes around about 4 or 5. Any more than that, and you're going to start coming head to head with Brooks's law. So the next question is, should those people be in-house or third party? Well, that very much depends on your circumstances. If what you are developing is essentially software, then I would suggest that you want them to be in-house. If the software is something which facilitates your actual product, I personally would tend to go third party. But that depends on your personal situation and your funding capability. But what is important is to have the right mix of skills in that. Now, everyone is familiar with, I would hope, the idea of what we call a front-end developer or a back-end developer, and possibly a full stack developer, which is a combination of the two. But you need more than that, because in addition to the right the right number of developers on your team and the capability of those developers to build what you want to build, we are now getting into the world of process. And when we talk about process, what we mean is this mysterious thing which is referred to as DevOps, development operations, and I'll get into more detail about that in a moment. So you're going to need the skills, tools, standards, processes, and pipeline that enable your team to be much more effective than they are, even at the level they are at now. That's the more important thing, the process, not the number of people. When I'm talking about process, there are essentially 2 elements to this. There is the people and project management element of it, and there is the software development element of it. The project management one is the easier to describe, and it's what you're probably going to be more familiar with. So if you haven't done so already, you're going to need to get yourself some mechanism for tracking and assigning tasks. Okay, now it doesn't really matter which one you choose. They're all much of a muchness. So whether it's Jira or Trello or ClickUp or just a bunch of Post-its on the wall, doesn't make any difference really. They all do roughly the same thing with differing capabilities and features. But the point is that you have a number of buckets, as it were. And the first bucket is what we call the backlog. So that's where everything that needs to be done gets thrown. Okay, you write it down there so you don't forget it. And the backlog is this big pool of things that need to get done. So you've got a massive load of things that need to get done and very few people to do them. So what do you need? You need focus and priority. So in addition to the backlog and how you manage the backlog, you need some other buckets. And the first of those would be what I would call next. So I'll describe how things move from backlog to next in a moment, but we have a bucket called next, a bucket called doing, a bucket described as in review, and a bucket called done. And I would also recommend a bucket called not doing, because there'll be things that you decide before you've started them that are no longer necessary. And if you just delete them, in 6 months' time, I pretty much guarantee you'll come back up with that idea, and you'll lose a load of time before you realize, oh, hang on, we decided not to do that 6 months ago. So if you've got a bucket called won't do or not doing, and you put things in there that you're not going to do, it'll stop you going through that cycle and wasting time. So how do you manage these buckets? Okay, If you haven't done so, you need to set up a cadence, and it needs to be weekly with your product owner stroke manager and your development team. I would recommend on a Monday morning, preferably early in the morning, so 9 or 10 o'clock, you have your progress meeting, or sorry, your priorities meeting, I beg your pardon. And the job in the priorities meeting is to take a load of tickets from the backlog, the ones that are important and that you, as the manager or owner of that project and product, need to have done that week. Okay, it's your responsibility to know what the priority is going to be in order to meet the objectives that you'd set up in the first place for growth. So you get to decide what it is that needs to be done, and you pull in the tickets that are relevant to that set of priorities into the next bucket. It's up to your development team then to take a look at that next bucket and all the tasks that are in it and tell you whether they've got a fighting chance of getting any of that done in the week that is ahead of them. So you're going to have to go through an element of negotiation until you reach the point where you and the team are happy. You're happy that you've set the right priorities. They're happy they've got a fighting chance of achieving them. From that point onwards, whenever your developers are doing something, they should be working on a ticket that's been defined, because if they aren't, you're going to lose track of what's being done. And they will take whatever ticket they're working on from the next bucket and move it into the doing bucket. And there should never be more than one ticket for any given developer in the doing bucket, because you can't do two things at once. So if you've been halfway through doing something and you need to move on to something else, you take that thing back into next and drag the new task into doing. When you've finished it, you move that task into in review, so that your testing team, if you have one, or your product owner or manager is able to actually look at what you've done and say whether it's correct or not. And once they've done that, they move the ticket into completed. Okay, that's the process. I would potentially recommend that you have a very brief 15-minute catch-up, say on a Wednesday, halfway through the week, just to make sure that nobody is stuck or confused about what they have to do, or has run out of things to do and is looking for something else, to make sure that they stick to your priorities. But what is also as important, if not more so, than your planning meeting at the start of the week is your retrospective at the end of the week. So on a Friday, I recommend that you ask your developers to demonstrate to you what it is that they have achieved. And it's an opportunity for them to tell you what didn't work for them, what went wrong, what you need to avoid in the future, and what went well that you need to do more of. So that's your cadence for product project management. Processes for software development are entirely different. And I've got 3 slides to describe these, because they are multiple and that most of them are things that you're probably not doing at the moment. And they relate broadly to 2 different circumstances. So your development environment, which is to say the world in which your development team lives and works and does what they do, and your deployment environment, which is what gets sent up to the cloud and that your end users end up seeing. So let's start with the development environment. You've got a team of between 2 and 4 coders. Up until this point, they have probably been doing pretty much what they need and fancy doing. Yeah, as long as they've been meeting the deadlines and the requirements that you've asked of them, I would be surprised if there'd been any discussion at all about what technology you're using, even, let alone what standards you're using, or what source control you're using. Okay, all of that has to stop. Now, everything has got to be managed. You have got to manage all of this. So let's start with standards. There are any number of code standards out there for whatever language people are coding in, but typically people will be coding in JavaScript or Python. I know there are other languages out there, but they are by far the majority of languages used in the context of startup. Maybe Java, but unlikely. So there are, as I said, a plethora of coding standards out there. I would recommend that you ask your senior engineer to choose one. Yeah, maybe it's the Google standard, maybe it's Facebook standard. It doesn't really matter, as long as everyone on the team is held to that standard, okay? And with the development environments that we have nowadays, things like Visual Studio or Atom, there are, again, a multitude of plugins that you can put into those tools that will test and measure whether your developers are sticking to the standards that you have set for them. They're called linting tools. And you can even set it up so that developers cannot commit code that doesn't pass the linting test, okay? I recommend you do that because you need everyone to be coding to the same standard. When we talk about source control, if you are unfamiliar with source control, it is the place where you put the actual code that your development team writes. And forgive me if I'm teaching people to suck eggs, but I have to assume that there will be some people listening who don't know what I'm talking about. So I don't want to lose them. So bear with me if you would. Source control is typically otherwise referred to as your repository. And in effect, source control is to software code what, let's say, Dropbox or Google Docs is to documents. It's a place in the cloud where you put your code, where your developers can share, and they can take that code at a given point in time and develop it from there and merge their changes back in. There's a lot more than that happens, but that's the essence of it, okay? Generally speaking, the source control that you should be using will be one of, well, there are a number of alternatives you can choose, but generally it will either be GitHub or Bitbucket, okay? If up until now you have been working with a third-party developer or even a developer on your own team who has been committing your source code to their repository, you need to stop that immediately, okay? If you as the CEO or the project owner or manager do not have your own source code repository to which your development team are committing their code, you leave yourself wide open, and I've seen this happen on a number of occasions, to essentially to blackmail, right? Because what happens, and as I said, I've actually seen this happen at least twice, but you know, various different forms more than that. Co-founders, one of whom is business and one of whom is technical, have a falling out somewhere down the line. And what the business co-founder didn't realize is that the technical co-founder has been committing source code to their personal private repository. So the relationship breaks down, and what happens is that the technical co-founder flounces off with all of your source code, right? You now no longer have a business because this person has taken your product with them. And I've seen people have to pay thousands of pounds in order for that person who's got the code to give it back to the owner of the business. Okay, it's happened. So if you don't have your own repository and source control, as soon as this talk is over, go and get it and get all of your developers' code put into it, because otherwise you're on a hiding to nothing. Why is source control important? It's important because we need to use processes which source control will provide us with, and I'll describe those later on. Another thing that all code uses is what we describe as modules. They used to be called libraries. Depending upon which language you're using, they may still be called libraries. But what we're talking about here is discrete elements of code that have been developed by other people that you use so that you don't have to develop those elements of code yourself. Okay, and everyone uses modules, hundreds of them. All software is made up both of your personal code that you've developed and also third-party modules. Modules are not necessarily safe and secure things to use, and developers are notorious for not checking that out beforehand. Even if we think they're safe and secure, they may turn out not to be. Anyone who's ever heard of Log4j, which is an open source Apache module that's been used in, I forget what the figure is, but it's 60 to 70% of all software. It was discovered last year that Log4j has a massive great security vulnerability in it, right? And vast quantities of the world's businesses have been running to try and plug that hole and fix that security vulnerability. So you need to decide and agree on the modules you're going to use. You need a reproducible environment. Okay, so your developers need to be using either containerization, which means Docker, or if you're using, for example, something like Python Django, which comes with its own mechanism for creating an environment, they need to be using that as well. Why do they need to do those things? Because those things are portable. If anyone has ever developed on Windows, they will be familiar from the old days with the phrase DLL hell. Okay, and what that means is someone has developed something on their local laptop or desktop, which requires DLLs, libraries, dynamic link libraries, modules, okay, the things I've just described, which exist on their machine, but when they export their code to someone else, that third party doesn't have those modules on their machine, so the code doesn't run, right? You need to eliminate that, and Docker and containerization or environments, managed environments like you get in Python and Django are the way of doing that, okay? So all your development must be being done in containerized environments or using an existing environment. You need a single code base, okay? So again, this is going back to reproducible environments. No longer will you be doing customization, so separate code bases for separate customers. That's going to take you nowhere. You will never be able to manage that. You need to move to a single code base which is configured for different customers. That is to say, you have a set of environment variables which may differ from customer to customer, and you have a mechanism that recognizes which customer is using your tool and therefore loads the right environment variables for them. If you're not doing that, then you are in deep trouble. Another thing that happens a lot, and I see this all the time, there will be things in code that we would describe as secrets. So they might be things like, for example, API keys that you don't want to expose to the rest of the world because you've paid money for that API and you don't want someone else piggybacking on your API because they've stolen your key, for example. The number of times I see API keys and things like it hard-coded into code bases is ridiculous. It must not be hard-coded. You have to take all of those things out and put them in an environment file, okay? I realize I'm running slightly short of time, so I'm going to speed up a little bit. So when we're talking about the deployment environment, as opposed to what we were just discussing, which was the development environment, there are essentially two things that we're looking for, which allow us to do the third thing, which is on the screen here. So you may have heard of continuous integration, continuous delivery. What's the difference between the two? Continuous integration is automating the mechanism for getting the code from your developers' laptops up to your source control repository. Continuous delivery is the mechanism for getting the code in your source control repository into your infrastructure in such a way that your end users can use it. Now, Puppet, who is a company that develops tools for enabling continuous integration and continuous delivery, they found that high-performing IT teams, in other words, those which could deploy and push code to production faster than their peers, experienced 60 times fewer failures and recovered from those failures 168 times faster on average. Right? Just digest those numbers for a second. 60 times fewer failures and recovered nearly 200 times quicker from any given failure. So it's paramount to have tools in place that can help you analyze and fix your development flow. So in the case of continuous integration, what we're talking about there is, I'm hoping that everyone here, whether you know it or not, has a development team that is using a mechanism called Git. So Git is your version controlling mechanism, okay? It's de facto the standard which is used. There are other versioning mechanisms available. I would not recommend any of them. So there is a thing called Git flow, which I recommend you get your development team to take a look at. In essence, what that means is that in your repository, you have two what we call branches. Okay, so you'll have the main branch and all of your live production code is in the main branch, okay? only one person ever gets to touch the main branch, and that's the person that you've assigned to actually publish new versions of your product or service. Everything else goes into a develop or a development branch, okay? You're going to need to be able to create in your cloud environment development, staging, and production environments. Okay, so a development environment is what it suggests. It's for your developers to put things into the cloud so that they can play around with it. Staging is for your testers, so it's after the development is finished but before you go live, and then production is for your live code that your customers are using. Beware, I say you need 3. You might end up just having 2, development and production, because these environments, each one of them is going to cost you more money, and it can mount up pretty damn quickly. As part of the flow for your continuous integration, getting your code from developers' laptops up into the cloud, you also want to be able to introduce, and there are many, many tools for these kind of things like automated testing. So you can run your unit tests. You can check dependencies. That is to say, look through all of the modules that your code is using and make sure they're at the latest version. You can check for security vulnerabilities in those modules. All of these capabilities are available as third-party tools that you can inject into your continuous integration pipeline. You must and should do that. When it comes to continuous delivery, Bitbucket and GitHub have themselves mechanisms for continuous delivery. In Bitbucket, they're called pipelines. In GitHub, they're called workflows. Your cloud provider will also have their version of continuous delivery. They're called triggers in Google Cloud, for example. So when it's your repository that's managing continuous delivery, you're effectively pushing the code out to your environments. When it's your infrastructure, you're pulling the code. Either way, it's doing the same thing. You can choose whichever one of those you think is appropriate and best for you. Coming back to this idea of environment variables and secrets, both in exactly the same way, both your repositories and your infrastructure should have the capability to manage what are called secrets and maintain them in such a way that no one else can see them, but they are accessible by your code when it's deployed. You need to think about things like what we call green-blue deployment. That is to say, if you've got 10 customers who are working on one production version of your code, and you want to bring a new production version live, you don't want to give it to all 10 customers at once, because what if you've got a critical bug in there? Okay, so green-blue deployment is the idea that when you create a new deployment, you have the new deployment and the existing one operating side by side, and there will be some mechanism that allows you to direct a proportion of the traffic that you can control to the new mechanism and a proportion to the old. So typically you would divert, say, 5% to your new deployment and 95% to the old deployment. That means only 5 people out of 100 are going to see the critical bug, which gives you a chance to fix it before you make it available to your general audience. With parallel development, what I mean by that is you are going to be wanting to achieve your goals of growth, but don't forget that you will have technical debt. So what you're going to be doing, I would recommend, is having 2 or more streams of development, which all of which, apart from one, are targeted at your end goals when it comes to growth. But one of them is a stream which runs in the background that can be put down and picked up depending upon your workload at any given time, but continues to be worked on over time, which is to remove technical debt or to address technical debt. The final element of all of this is the infrastructure. Now, this is there are 3 main providers of cloud infrastructure. They are Google, they are AWS, Amazon, and Microsoft Azure. And to a certain extent, Heroku is also coming into this as well. But the 3 big players are AWS, Azure, and Google. AWS have been at it the longest. It doesn't really make much difference which one you use, because all of them contain a mind-bogglingly complex array of different things that you can use to set up your environment. That's why I say infrastructure is a specialist role. Whichever of those providers you are using, you need someone in your team who knows what the hell to do with that infrastructure. Even if you're bringing in someone as a third party or talking to, for example, Google engineers directly and getting them to do stuff for you, you need help. You cannot do this without someone who knows what they're doing. Because what's going to happen is that you're going to end up with a very, very expensive solution if you're not careful. I'll give you an example. One of my current clients is on Google Cloud Platform. All the code was set up initially using a Google product called App Engine. Google then released a new product called Cloud Run, which is almost exactly the same as App Engine, but there is one major difference. That difference is very significant. App Engine is paid for all the time, whether your end users are using it or not. Every second that an App Engine instance is up and running, you're paying for it. Cloud Run is completely the opposite. Cloud Run shuts down when no one is using it, and when the next person comes along, it starts itself up again, and you only pay for the time that people are using Cloud Run. The difference in cost is significant. So we're in the process at the moment of migrating all the existing deployments that are in App Engine to Cloud Run. So you need to get advice on what is the cheapest and best way to organize your infrastructure. There's a lot more that I could say, but I see that I've only got 10 minutes left for you to ask questions. So to reprise, 4 elements of scale are objectives. Why are you scaling up? What do you want to achieve by scaling? Looking at your team, simply throwing people at the problem is not going to solve it. But what you need is a small number of the right people. And in order to make those people effective, you need to provide them with the processes which they require to take away any thought and any time spent by them managing the code. Okay, they should just be focusing on writing it. They should be able to click a button and everything that happens from that point onwards is done automatically to get that code into your repository and in front of your customers. And that will depend on your infrastructure, the infrastructure you choose and how you choose it carefully to make sure that it is appropriate and costs you the right amount of money for what you're trying to achieve. And at this point, I'm going to give you all a break and say thank you very much for listening. If you have any questions, feel free to ask them now. I'm on Slack, so you can continue to ask me questions afterwards should you wish to do so. I've been Paul Niebel. Thank you very much.
Thank you so much, Paul. Oops, let's take those glasses off. Thank you so much. I was going to jump in quickly and say feel free to go for an extra 5 or so minutes, just because I feel like I'm aware that we are recording the session, so people are obviously having the ability to go back, and that brings me on to the point of, please do feel free to, you will get an email from us, obviously as a follow-up email that will have the recording and a slide deck in there for you, so that you can obviously always go back to the content and sort of, look back at it, because I appreciate there's a lot of content that Paul has thrown there at you. But in such a wonderful way. I always enjoy listening to you, Paul. It's really nice. We do still see your screen, just let you know. So if you want to stop sharing, cool. Thank you so much. Yeah, so we will share the recording with you, so you'll be able to listen back. You'll be able to, digest the content a bit more if you do wish. So in the follow-up email, you get all the information. So I appreciate that we might run a little longer than on the hour. So if you do have to dash off to another meeting, or just really want to enjoy your lunch, then that's no problem at all. You'll be able to finish the content with the recording link once you receive that on email. So yeah, please feel free to use the question section as mentioned at the start of the webinar to raise your questions now. This is your chance to fire anything at Paul, well, not anything, but kind questions at Paul, related to the subject. So that would be fantastic.
We did have, the reason that I brought that thing up into my screen that you saw when you mentioned is because we did have one pre-submitted question, which is,
I will ask you that now.
Yes, yeah, absolutely.
Yes, it is whether you have any advice on how to manage regular data sets to a product that comprises a data set and models. So yeah, I appreciate that's quite a big question, but obviously, please, if you have any advice, I'll fire away.
Sure. So we're talking about updates to things, models that use, for example, land registry data, which we know will change on a monthly basis. I can't go into exact detail about that because it's quite complicated, but essentially, so anyone who has used computers for more than the last 20 years will be aware that this wonderful thing that we see in front of us, which is the graphical user interface, Mac OS or Windows or whatever it happens to be, Linux, these things didn't exist 20 years ago. So when people like me started computing, we were using DOS, MS-DOS or Unix, right? And all that is a screen with where you type stuff out, right? That's how things used to be, you kids, right? And we didn't have mobile phones either, but I won't go into that. My point is, there is a thing called the command line. And on a Mac, you can open up Terminal and it gives you a command line. So with the command line, what you can do is you can create scripts. And so I've done this in one way in the past, which is I've created a Docker container with a series of scripts which will go and download the land registry data from whichever site I've told it to go to. I'm giving it the URLs. And by the way, I created this thing so it's configurable. So I've got an environment file it uses so I can change where it goes and gets the data from whenever I want to. We'll go and read the data, bring it down, run some other scripts with other tools like GDAL and Tippecanoe, for example, to take that data and extract it into a tile set, and then put that tile set up into Mapbox or into my local hosting if I'm doing it locally. You need to write scripts, okay? You need someone who knows preferably something like Python, but not necessarily Python, shell scripting, that sort of thing. But I'd recommend you containerize it again so that it's portable. And you can also create things called cron jobs. And a cron job is essentially a set of scripts that runs on a schedule, and you can define what the schedule is going to be. But basically, that's the way you're going to go about doing it. You can do it on demand as well, but we want to automate this stuff. So why not just set it up as a cron job and a script that runs once a month? All of the major cloud hosts will have a mechanism that allows you to set up a cron job to run scripts to do exactly this kind of thing. So that's how I would do it personally.
Amazing. So if that answers the question, which I hope it does, that's definitely a really useful response there. Then if you have any follow-up questions, of course, again, please put those into the question section. We'll be happy to get around to those as best as we can. Could you just please go into a little bit more detail explaining DevOps?
DevOps, yes. Okay. So DevOps is everything that happens after the source code has been written. Okay, so your development team, whether they're front end, back end developers, full stack, whatever, their job is to write the code that gets the right thing on the screen, right? And they will do that on their laptop, or if they've got a desktop at home, they'll do it. And we describe that as their local environment, because the code they're writing at that moment in time only exists on their computer. Now, there are ways you can get around this. I didn't go into this in detail, but there is a growing recommendation that the development tools that you use, for example, things like Visual Studio, those are now available in the cloud so that they don't necessarily run, they're not installed and run on your local laptop, you're just accessing a cloud version of them. I'm a little bit wary of that because if anything happens to your internet access, then you won't be able to develop, but that's probably true anyway, even if it's locally. Anyway, the point is, they will be developing code on their local machines and running it up and checking it and going, yeah, that works, yeah, I'm happy with that. And then they'll reach a point where they say, right, this task that I've been working on, that I've got a ticket for, that I've moved from next into doing, okay, the thing that I'm on, I'm done with that. So now I need to put that code back into my source control, okay, so that it is available to the rest of the team for the latest version. Everything that happens from the moment that your developers have finished creating their code, from that point onwards, all of that entire chain is what we call DevOps. So the fact of your developers being able to commit their code to the source control, the fact of if you've set up, for example, a workflow in GitHub, and you set that workflow to be triggered by a commit, So your developer commits their code, that triggers a workflow. What that workflow does is it takes your code from your repository and it puts it in the cloud. All of that stuff, that entire process and everything that's in it is called DevOps. The process of creating the infrastructure in the cloud that sits at the other end of that pipeline, that's DevOps. So in other words, setting up your databases in a project, setting up your Cloud Run instance that actually, serverless instance that actually runs the code that talks to the database, creating a load balancer, and creating a URL that points at the IP address of the load balancer. So when you've got lots of people accessing the code, it automatically spawns new versions of that code so that the performance doesn't drop and the whole thing doesn't come to a crash. All of that stuff, that's all DevOps. Now you can see that that is a massive area. It is a massive area, right? Your developers are doing a brilliant job in their massive area, but you don't want them to be having to mess around with DevOps because it's just going to distract them and take time. So you need someone who sits at the other end waiting to receive their code and make all of the other magic happen. And that's what DevOps is.
Wow. I'm learning something new every day as well. That's great. Thank you so much. Goodness, that sounds quite daunting. Maybe we should do a webinar on that. Wink. But I mean, in all seriousness, if that is an area that you are indeed interested in, please do let us know, because that brings me beautifully onto quickly onto Matt actually saying thanks all. It really was, he needed to go, but a very useful session. So thanks so much for the feedback. I have shared with you all the feedback link to just get some sort of insight as to how you found the session today and what you'd like to see more of in the future. And that's quite crucial because as an events manager at Ovation, I always want to make sure the content is relevant to our community and to the industry and, driving innovation. So I want to make sure that you guys can do the best that you can and that you can, move forward into the future with as much skill sets as you can have. And so obviously the sessions that I host, I want to make sure are relevant to you and are helping you clear the blockages that you might have. So if you do have any thoughts on that, please do complete the feedback form. You'll get a link into that in the follow-up email also, but it is also in the chat at the moment as well. So please do give us your thoughts and insights. So that's really, really helpful. Also Alex saying, thank you very much for the presentation. He also says, I recommend using cloud platforms to reduce risk and speed up the development pace. Is there any funding you are aware of to reduce the cost of these platforms?
Well, through being a member of Geovation, yes, you get, I think it's 10,000 credits or something on Google. I mean, of course, that does mean that you're going to end up using G-Cloud, but to be perfectly honest, they're all much of a muchness, whether it's Google or AWS or Microsoft Azure. I would only tend to use Azure if I was using a full Microsoft stack, so C++ development, Visual Studio, all the rest of it, and that whole suite is really well integrated. You can apply. I do know that Microsoft does have a scheme. I can't remember the name of it, but if the person who asked me this question asked me the same question in Slack, I'll find the name of the scheme. Microsoft has a scheme that you can apply for, and if they deem you to be fitting with what they're looking for, you'll get a whole load of like a year's worth of credits from Microsoft to use on Azure as well. Beyond that, I mean, it's like anything, right? When we tend to think that these tech giants, what they say goes. If they advertise it as being this amount of money, you can, in just the same way that you can walk into Curry's PC World and speak to someone there and say, see that computer there? I'm going to buy 2 of them. I want a 10% discount. And they'll go, yeah, sure. They will actually do that. Yeah. You can do the same thing with Google. You call Google up and you say, I think I want to use your infrastructure, but currently we're on AWS. They'll go, oh, here, have 10,000 credits. Have a year free on us. They want you to come to their platforms. So don't be shy of asking for a deal. I'm not guaranteeing you'll get it, but there's a fairly strong chance you will.
Maybe I should run a session on negotiation skills.
Yeah.
I mean, I guess I always find that it's a really, really helpful tip, actually. I think, we're very often very shy in sort of thinking a set price is a set price. You can't possibly sort of, jingle your way around possibly getting something else out of it, either adding value to the price that they're stipulating or reducing the cost for that particular item or product. So thanks so much for the encouragement, Paul. I think that's really cool. So if you have any more questions, please feel free to email or to message them now. I think it goes without saying that it's been a really, really informative session, and it's been really, really insightful. As I said, I really enjoy listening to you explaining things always. It's really, really nice to hear that. So if you have any questions, because of course we appreciate that there's a lot of information, and that is, you have to really think about it, digest it. It might only make click in some places in a day or two or a week or a month, but please don't be shy to obviously reach out to Paul directly. We'll make sure we'll include all of this information in the follow-up email also. But also you can email us at events@geovation.uk. I muddled up my punctuation there. Sorry. So if you email events@geovation.uk, I'll make sure that you can reach out to Paul as well, or we can direct you into his direction. Sorry, that again wasn't particularly proper English. And as Paul mentioned, he is on Slack. So if you are a Geovation member and you are on our Slack channel, then you can reach out to Paul directly there as well. And again, that brings me nicely onto having shared the membership link as well with you. If you are not yet a Geovation member, then I think you should. It's free of charge anyway, so you have nothing to lose and everything to gain. So including access to our Slack channel and hence therefore Paul. There we go. what better way? Yeah, please do consider signing up for that. And again, I will include all of those details again in the follow-up email so that you have it all ready to hand. But in case you've already seen that, then you can sign up now. But there are no more questions at the moment. And as I said, if you have more questions, please don't be shy on reaching out. We are always happy to help. That's what we're here for. Yeah, we'll hopefully see you again in the future. And I'll probably share some events that are coming up with you in the email as well. I won't bombard you with that because I appreciate we have overrun now a little bit. So there we go. But thank you so much, Paul, for running the session for us today. It's been really, really, really good. Not that I'm surprised, of course. But thank you so much, everyone, for joining us today. I know that these webinars are so far, and there's so many of them nowadays. It's really hard to navigate through a lot of these happening, but it's really, really wonderful to see you all here and joining in today. So thank you so much for your time, and yeah, we'll see you at another event, I'm sure, in the future. Thank you so much, everyone.
Bye.
Have a good day. Bye.